各位观众朋友，大家好！您现在正在收看的是2024年柏林国际轨道交通技术展览会中国中车的现场的直播。我现在正在为您进行的第2场全球的直播。上午呢，我们有2款全新的实车进行发布，不少的朋友也是非常的感兴趣，想要更多的来了解我们的产品。所以呢，下午我们专门安排了一场技术发布会，由我们中车的技术专家来为大家做一场技术发布。瞧，技术发布会开始了。
Distinguished guests, ladies and gentlemen, good afternoon. My name is Kevin Chu, and I'm your moderator for today. It's my pleasure to welcome you here to the CRRC CINOVA H2 New Energy Intelligent Intercity Train and ART 2.0 Technical Conference. This morning, both CINOVA H2 and ART 2.0 system has been officially unveiled. And during this conference, we are going to look into more details of both new technologies. Starting with the new Energy Intelligent Intercity Train. Before the presentation, let's watch a video first. And now let's invite Mr. Yuan Qu, technical engineer from CRRC Japan, to tell us more about CINOVA H2.
Thank you, Kevin. Dear guests, it's my pleasure to give you an introduction, a brief introduction about the CINOVA hydrogen trains we have newly developed. Moment. Okay. It's all start with a demand analysis, like how we develop and produce a train, an intercity train with hydrogen powered. We did a research first. Now you can see here, according to UIC, roughly 66% of the lines around the world are non-electrified. And we believe that's an area we could work on. And on the other side, we did a small investigation domestically in China with our customers to see what's top-level requirements, demands from their operation experience. And we summarized 4 key points here. Normally, they're asking for a speed range around 160. Of course, the higher, the better. Then they want the train to be compatible with various line conditions, like different weathers, different track alignments, different operation scenarios. Then one case in China is special is like the Intercity train actually have a connection with the metro systems. So we are foreseeing a dynamic passenger flow in different timing around the day. So they want us to have variable passenger load conditions to accommodate such change. Then of course nowadays everybody asks for condition monitoring. They want to collect the data from operations so they are able to process the data and to predict the failure. So that's our demands. Then we also try to answer some questions like how to achieve eco performance, because that's important, and how to guarantee endurance mileage, and how to increase the passenger capacity as much as possible, and how to enhance the ride quality. Those are the questions we try to answer. So we break down the demands. We have some top-level principles and core text summarized here. The new train must be green, intelligent, safe, and adaptive. Similarly, for the core text, we summarize the system integration level. It must make the train work. The hybrid power may be needed because depending upon the operation scenarios, we don't stick on one single source of power. Condition monitoring, we need to have such data acquisition abilities, then intelligence service for a better passenger experience. So those are the core texts we summarize. I will go through it shortly, one by one. Then before we start development, we try to set up the baseline as well. A brief introduction to you is for Intercity rolling stock platform. We have established the platform several years ago. Until so far, I believe we have delivered more than 172 train sets in domestic customers, and with accumulated mileage around 220 million km in China. So we have that proven experience on that side. On the other side, we talk about hydrogen fuel cell. CRRC is the first one to introduce the hydrogen-powered tram in China. Then that was in 2017. Then we put that train in commercial operation around 2019. So far, I believe we have 500,000 kilometers running mileage. So both rolling stock and hydrogen technologies, existing hydrogen technologies, are the baseline of our development. So we start with system integration. We set up some top-level index here. The operation speed of the train at normal condition is around 160, but we try to raise it up to 200. Then endurance mileage, we are targeting somewhere 1,200 kilometers, of course, under defined conditions. Then we try to limit the hydrogen consumption below 0.3. So in order to achieve that, we need to have high efficiency, low resistance, lightweight, and high capacity. For high efficiency, now the overall system efficiency is around 90%. To do that, to achieve that, we have the onboard hydrogen fuel cell here. We have the power battery, which is LTO at the moment. And also we have SiC converters and DC-DC. We try to use permanent magnetic traction motor as well. Low resistance, especially error resistance, especially when we're talking about the running speed up to 160, that's quite important. So we did a lot of wind tunnel tests and rolling resistance tests in order to optimize the front shape and in order to characterize the critical areas like the deflector on top or the skirt at the bottom. Try to reduce the surface drag. For the lightweight design itself, we have implemented carbon fiber material very often in our new trains. We have carbon fiber for the deflector, as well as the equipment cabinet underneath the train. Then we have, as I mentioned, SIC power converter. And we also have recorded topological optimization for the car body and the body. We use this technology for the construction of these major, let's say, load-bearing structures to reduce the weight. So overall, the train you see outside, right now, the dead mass of the train for a 4-car train is around 206 tons, considering a 103 meters long. And for high capacity, we do have several methods we tried, and those are the current situation. The first one is a fusion, we call it fusion design. As you can see from the screen, the initial cabinet, the size of it is huge. And we developed our own logic control unit, which you can consider as an I/O hub. So we use LCU logic control unit to replace the traditional relays and circuit. In this way, we successfully reduce the size of the cabinet. It's not only at the number 2 end. We did it for all the other locations, so we have additional space reserved for standings. And another kind of thinking we have is, we call it seat conversion. Please go outside and try. After this conference, you can go outside and try. We do have this automatically rotatable seat arrangement over there. We have interface, we have control reserved. So depending upon the timing or the situation of the operation, you can rotate to create more standing space. As I mentioned, there was one case. The Intercity train has connections with metros, with the other public transportation systems. So that's why increasing standing space for us, for the case in China, is kind of important. And of course, right now, we call it flexible layout. We have all interface reserved. We are prepared to have customized design. We can change the seat layout, orientation, face to face, back to back. All these interfaces are already embedded in a structural design. So overall, we are looking for a seating capacity around 236 and a maximum capacity around 1,000. Now let's talk about the hybrid power. Basically we use HFC and LTO as the power combination of a power source. For the charging of the hydrogen, right now we are trying to finish the complete charging within 15 minutes, considering 2 injection ports on the train. Then the fuel cell will be the major source of the motor. But we also have a power battery. That's because at the initial, the constant torque range, and the initiation of the motoring, we try to have some kind of power-oriented mode. So we use power battery at the beginning of the motoring. Then once the preset threshold is passed, then actually the HFC will take over the major duties. Also, we want to try some recovery technologies, like for example, the thermal energy reuse, because we have the cooling water from the fuel cell itself. We collect this cooling water and we introduce the water to our HVAC system. So in the winter, we can use this as an additional thermal source for heating purpose. Another recovery we did is for the byproduct water, because due to the reaction of the fuel cell, we will have water generated. Same thing, we collect the water, we introduce them to the toilet unit for the toilet use. In this case, we successfully reduce the water tank size and reduce the weight of the train. So the fuel cell itself, right now the nominal output is 240 kilowatts and the power density 160. We are looking for overall system efficiency around 45%. Then the design life, according to the current configuration, we expected the design life to be 35,000 hours, which roughly equal to 7 or 8 years, like according to the operation scenarios in China. So it's aligned with the overhaul arrangement. That's our thinking behind it. Of course, safety is critically important. In order to achieve that, we did many tests, verifications. For structural strength, we have 12 type tests, including dropping, penetration, bullet test, stuff like that, to verify the structural integrity of the tank itself. Then for the leakage detection, we have 16 sensing tests. We are now trying to adding additional sensors. We try also to use the existing data to create kind of algorithm to indicate the status of the system. Then for flame detection also, we have 4 sensing tags. For the injection prevention, of course we have an anti-explosion design. Condition monitoring, nowadays digital twin is very often been mentioned. For us, same thing. On the physical side, we want to make a connection between the physical side and the digital level. So right now we call it condition monitoring modules. We have in total 36 modules implemented on board, which covers the major system for the FC itself, and also for the structural health monitoring system, which are the sensors we put on the critical locations in a structural variance area. For the critical circuitry, of course, we have monitoring and troubleshooting indication. For the vehicle dynamics, we have ride quality, derailment, and also the system can picture the critical resonance between the train and the truck. Optionally, for truck irregularity measurement, we offer the interface to have additional inspection capacity for irregularity, track alignment, propagation, geometry, stuff like that. Of course, this is available. Then once we have all this data collected, we developed a system, a platform, we call it Smart Care. Smart Care is kind of operation and maintenance management system. By collecting the data initially from the train, then there will be a processing at the wayside server. So it will predict the failure patterns. It will check the status of the train, or it can even automatically create any work orders if necessary. So actually, this is a typical setup in China already. Then looking forward, the maintenance perspective by different kind of optimizations in manufacture, maintenance, and operation, we are able to create an overhaul interval around 1.45 million here, which is roughly 7.5 years, according to Chinese operation scenario. Intelligence service is more based on our drivers, the people on board. So we have screens for passenger, we have information push broadcasting for passenger, we have UI design dedicated for driver, we have UI design dedicated for technician, and also CDM capacity for the maintainer. I suggest you go check our physical car. We will have stuff to show you around all of this. Of course, boarding guide, journey service, we will have. And one important thing of our proposal is CRRC is not only a rolling stock car builder, we are also providing an entire solution as much as possible. So for CINOVA hydrogen train, right now we have a full coverage of a supply chain, starting from hydrogen producing, storage, automation, automatic refueling, then to the design and construction of the module itself, eventually to the train. So CRRC is able to deliver the entire system-wide solution. Okay, then this one is kind of our vision for the future. Let's see if we have proven technology and proven products by using hydrogen, then that will be a future we are looking at. We have hydrogen tram already, and we try to use that technology into kind of suspension rail or straddle rail. And now we have our Intercity train. So in the future, we foresee a better possibility. Then we did a rough calculation. Considering an annual mileage around 300,000 km per year, which is typical in our scenario, we will have a carbon emission reduction around 730 tons. So that's the responsibility of CRRC, I would say. Okay, that's about it. Thank you very much.
Thank you, Mr. Yuan. And now let's move on to ART 2.0 system. Again, let's watch our video first. And now let's welcome Mr. Zhang Chenlin, engineer from CRRC Zhuzhou, to introduce ART 2.0 system.
Ladies and gentlemen, good afternoon. Welcome to our presentation today. We bring a new type transportation to us, which part of the CRRC ART. My presentation will include 4 parts. First, what is ART? Due to the guiding, carrying, and the concentrating effects of the wheel, the trains have large capacity and high efficiency, making them the backbone of urban public transportation system of the country. However, due to the strict smoothly of the rail and other requirements, system construction and operation is complex and costly. So engineers continue to explore new type of trains, simplify the requirements of the train for rail structure, and innovated monorail trains and guided rail trams, transforming physical rail from double tracks to single tracks. Without the physical rail, there are inherent intelligent challenges that the long formation trains faces, such as instability in straight lines and difficulty turning in curves and non-pass sweeping. Can we completely alter the dependence of trains on physical rails, which would be a new technological challenge? ART has overcome the virtual rail technology and of electronic guidance and trajectory following technique. We achieve precise movement of the rubber wheel on the water wheel. Without physical rail constraints, we replace the steel wheel and steer wheel with the rubber wheel and the water wheel. Up to power technology. The first is the intelligent driving system. Our intelligent driving system is based on the computing platform and the laser radar and other millimeter wave radar. Through the automatic passenger control system, the vehicle's first axle is stably track the face of the water wheel and driving command. The vehicle can realize SA level 4 high operation in particular scenarios and R2-3 drivers driving without ground signal system. Trackless guidance system. The CINOVA trackless guidance system is based on the breaking guidance control method. We base the first axle of the track follows the water wheel, and this system is making sure that the other axles follow the running trajectory. So the straight line following duration will be less than 0.1 meters, and the total following duration will be less than 0.3 meters. Number 3, CRRC ART2. CRRC ART gives a streamlined timing, low cabin design, and asset capacity. So the seat arrangement and the paintwork can be customized according to the requirements. There are some parameters of the CRRC ART, like that the vehicle capacity will be more than 300 per person, and the vehicle's length will be 30,800, and the width is 2,650. The pace of the vehicle will be 3,650. The wheelbase will be 7,000, and the floor height in the passenger compartment from ground will be less than 330, and the passage width of the passenger door will be more than 1,003. The door spacing will be 1,000. and the passage rates in passenger compartment will be more than 800. Approach angle and the departure angle will be more than 80 degrees. Also, the design line will be 30 units. The CRRC ART will be more energy efficient. We use lightweight designs such as structural lightweighting, motor lightweighting, so the service rate will decrease 36.4%. The traction and GCV will increase 20%, and we use lighter axle load will be less than 9 tons. The tire ground attachment also will increase to 75%. There will be more energy recovery. Maximum energy recovery of electrical braking will be 800 kW, and the energy recovery ratio will be more than 60%. So energy consumption per capita per kilometers will be less than 0.01 kWh. The ART will be more greener. We use electrical driver like where half motor drive and where 8 motor drive. And there will be multiple supply methods such as hydraulic fuel cell batteries and ultra capacity. Fast charging for 5 minutes. They increase the insurance village by 20 kilometers. And we have low battery capacities. When we powered by the fast charging batteries with a range of up to 100 kilometers. When we use the hydraulic fuel cell with a range of up to 390 kilometers. The ART will be more simple. So we use redundancy design, such as redundancy design of the control signals and the electrical and the pneumatic controls. There will be some active security technologies, such as automation protection against the abnormal vehicle produced external intrusions. And we have intelligent driving, such as zero-speed start, cruise control, 4-speed domain adaptive cruise control, and auto-stop. Also, our traffic guidance system will be therefore the high quality. Our ART is very can be customized interior and exterior design. So when we use rubber tires with the low operation, low noise, low construction of stereos and power supplies. So, and our chain will be 100% low flow design and 30 years certified. And the CRRC ART have outstanding vehicle performance. For example, the maximum operating speed will increase to 100 kilometers, and the average acceleration from 0 kilometers to 40 kilometers will increase to 1.0, and the maximum surface braking acceleration will be more than 2.0. I adapted what CRRC ART is comparable with various application scenarios, including roads, bridges, overpass, and tunnels. Normal operation can be in high temperature, in low temperature, and rain and snow environment. And the CRRC ART is very highly adaptable to the roads. The minimum toll radius will be 50 meters, and the maximum range is 30%. It can realize automatic driving on 3.1 meters wide complex roads. We use modular designs, so the vehicle condition can switch between 2 to 5 levels, and it can satisfy peak and off-peak requirements. For strategy, we use signal priority, so the train can run on the cities with navigable right of way and intelligent transport. Centrally, CRRC ART is centralized integration through multi-standard control centers, achieve the largest and biggest. And the CRRC ART will require super operation, secondary cell lines and stations for interchange. And when during the operation, simply release of the golden resource to be shared with other vehicles. Other applications. We compared our CRRC ART to other system vehicles like AAA, Trolleybus, and BRT. We can see that our CRRC ART's capacity will be 5.2 50,000 person per hour. And we have more choice to the energy supply method. Also, the traveling speed will be 20 to 35 kilometers, but also the construction period will be less than 10 months. The CRRC ART can travel between branches and very comfortable, just on the open road resource. By conclusion, we see that there were many advantages of the ART. For example, simplicity, low cost, and the infrastructure, short cycle, flexible, adaptable, high quality. So in large cities, the CRRC ART can be a supplement and link for the metros to solve the last miles problem. In small and medium cities, the CRRC ART is a main body or backbone for the urban public service as a metro. And in some specific zones and transit systems, CRRC can be the site C public transit system. And in functional area of specified algorithms, CRRC ART can be the backbone of urban public transportation system. To make the city better. Thank you for your attention. See you at the CRRC 2. Thank you.
欢迎回来！您现在正在收看的是2024年柏林国际轨道交通技术展览会中国中车的现场，我们现在为您进行现场直播。那么柏林展呢，是我们全球最重要和最全面的轨道交通工业成就展，在我们的世界轨道行业呢，堪称是我们的奥林匹克盛会。那我们的中车作为全球规模领先、品种齐全以及技术一流的轨道交通装备的供应商，可以说是我们这场盛会的明星选手。那么每一次我们参加展会呢，也会吸引不少的目光。那此次我们的技术展览会，中国中车带来了哪些新的技术和新的成果呢？下面我们就为大家一一的进行揭晓。首先呢，我们会来到我们的展台客运展区，有请我的同事尹航为大家做介绍。尹航你好。
安琪你好，大家好，我叫尹航，我是咱们中车的这个讲解员。然后呢，咱们现在看到的呢是这个旅客服务的这个板块。这个板块呢主要是分为4个平台。那么咱们呢现在看着的是第一个平台，是这个新能源的这个客运服务这个列车。
是这个平台吗？我们看也有我们的观众在向我们的讲解员去了解。
是的，是的，这个是一个非常热门的一个平台，就是咱们刚才发布的那一款产品。那么这个新能源的这个它这个属于城际动车组，那么主要是呢为咱们这个非电气化的这个铁路提供这种低碳的这种解决的方案。
好的，我看到前面我们还有一些透明屏，它展示的是。
好呀，好呀，我带您去看一下。那么这个平台呢，就是咱们这个城际和市域车的这个动车组的平台。那么这款车型呢，它主要是用于咱们城市的中心和这个卫星城之间的这个连接的线路来用的。然后呢，咱们中车也是特别的贴心，为咱们的这个参观的朋友们啊，准备了这个大屏，非常的炫酷。然后呢，也可以了解到很多的这个相关的信息。然后安琪，您试着
我展示一下。
好好好。那边
我们看到我们的透明屏，应该是可以，
您可以试一下这里。
比如说啊，我们来随机来选择一个。
好，您随意。这样，然后这里
是能看到
可以的
内部构造和介绍。
对，这个是咱们的这个车辆的主要信息。然后呢，如果说咱们想看咱们车辆的这个。
那我们这个平台这次带来了哪些产品呢？
咱们这回呢，这个平台带来了2位明星产品。那么第一个呢，就是咱们的这个 CINOVA 2.0的这个平台。那它具备呢有这个智能先进、绿色环保，然后乘坐舒适的这样的一个特点。然后第二个呢，明星选手呢就是咱们这个市域新型车，这个呢也是即将在咱们这个上海的这个机场联络线上来应用的啊。那安琪，咱们可以再往下的往前面去看一看，
看一看下面还有什么产品。
好。往这看这个，安琪第3个平台呢，就是咱们这个智能城市轨道交通这个平台。那这个平台呢，它包含了很多的车型，比如说像地铁车，然后轻轨车，还有很多这个悬挂式单轨呀，就咱们之前说的熊猫车，然后还有一些低速的、中低速的磁悬浮就各种各样的车型。
应该还有咱们上午发布的智轨2.0。
对，非常的神奇啊！就车辆可以自己的寻走这个轨道的踪迹。然后呢，也是如果游客呢想了解更多的信息，就可以通过咱们这个触摸屏来做这个具体的产品的了解。
也可以切换它的中英文的界面，对吧？
对的，非常的贴心。
这边还有一个平台是
这个呢，是咱们这个智能化高速动车组的平台。那么这个呢，就是顾名思义啊，就跑得又快，然后又聪明。所以呢，车辆呢装了很多的这种新技术，比如说像互联网技术，然后云端的这个计算技术，还有高速的传输技术，还有5G技术等等等等那安琪，您知道那个雅万高铁吗？
我早就注意到了，我们墙体上放的这个车体的模型应该就是我们的明星产品。
是的，非常热门的一款明星产品，是咱们 CRRC 出口到印度尼西亚的一款动车组产品。然后它的最高速度呢可以达到350千米每小时，非常的快。
我相信咱们镜头前的观众应该对这款产品也并不陌生，备受瞩目，可以说是。
是的，是的，非常的漂亮。
对，我有听到我们印尼的朋友帮它亲密的称为咱们的红色科莫多。
是的，就是它包含了一些印尼的元素。然后呢，它是去年的10月份就在印尼正式的开通运营了。然后目前为止呢，已经有230多万的印尼的这个乘客来乘坐这一款高铁列车，而且反响呢是非常的发好。
好的，谢谢。刚才听到了你的介绍呢，我们的客运展区呢，客运的系统解决方案呢，应该是有很多的明星产品。
是的，是的。
也希望我们的明星产品呢，能为更多的国家和地区的民众送去更美好的出行体验。
是的，欢迎大家来参观我们的这个展区。
好的，谢谢尹航。
好。
那么，听完了这个客运展区呢，接下来我们跟着我们的镜头继续向前。
领导这个麦给你。
大家看到这个区域，现在这个区域呢，向大家展示的呢，是我们中国中车向全球各地的征集来的优秀的绘画和摄影的作品，大家可以近距离的来观看一下。很多的作品都非常的精彩啊，它展现了我们中国中车连接世界、造福人类的精彩瞬间。好，摄影师也注意到了这一幅呢，我个人来说呢，是我最喜爱的一幅。大家看，它是中国的传统的国画和我们高速中的这种高科技的一种融合的画面的体现。大家注意到啊，上方的这个题词也是非常的传神和应景。青山秀水出蛟龙，非常精彩的一幅作品。那么我有了解到呢，像我们这一些作品呢，经过个人的同意，中车呢也是举办了一场义卖的活动，所有的义卖活动的收入呢，也是捐赠给了当时悉尼大火受灾的民众和一些野生动物的保护方面。好的，下面让我们的镜头继续向前。好的，现在我们来到呢是我们的产品家展区。我看到我们的张猛家同事早早的等在了这里。猛家你好。
你好，你好。
为大家介绍一下吧。
好的，好的。嗨，大家好。嗨，大家好，我是张猛家。今天很高兴为大家介绍面向产品家的 TIES 车地一体化机电系统和全生命周期解决方案。通俗的讲 ，TIES 它就像是一张大网，把围绕在车辆专业周围的各个机电系统给串联起来。那么长期以来，传统机电系统其实一直面临着诸多的问题，比如说能源利用效率低、人力成本高、效益提升难度大等等。
那么对于这些难题，我们中车有没有提出什么解决方案呢？
中国中车因为更了解车辆，我们凭借多系统、跨专业的系统集成优势，推出了面向车辆和地面集成系统的融合解决方案，这就是 TIES。那么大家请随我看。现在在屏幕正中为大家演示的就是 TIES 车地一体化机电系统的一些典型的应用场景。
可以说它是一个集成化的一个业务模式。
TIES 由5大关键子系统构成，分别是信号、供电、公务、断场和乘客服务。我们通过将车辆与5大关键子系统的物理设备和控制功能相互融合，就能够实现信息流、控制流和能量流的交互联动。
我注意到现在这里是5个显示屏，那么我们第6个显示屏是？
安琪，您说的没错。除此之外，产品家服务还提供完善的全生命周期服务。
是这一块吗？
是的，是的。全生命周期服务能够提供从产品的交付、运营、维修到最终报废的全部的过程都能够实现覆盖，能够实现产品与服务的深度融合，大幅度的降低全生命周期的运维成本。就是这样。
好的，谢谢。相信有了我们产品家的这个服务的加持呢，我们刚才提到的很多的难题就能迎刃而解了。那么除了我们的产品家的这个服务啊，我们中车近年来呢还一直致力于推广我们的系统家服务。那么我们看到我的同事季文轩也等在这里，文轩为我们介绍一下我们的系统家吧。
好的，大家好，我是季文轩，欢迎来到咱们的系统家 DRLS 板块。 DLS 呢，它的全称就是 Digital Life Cycle System Solution， 也就是数字化的全生命周期系统解决方案。那么我们的主要是致力于为客户带来从数字化、智能化技术下手，从建设运营一体化全生命周期的系统解决方案。同时呢，可以提供涵盖工程设计、建设管理、系统集成、运营、维保的全链条数字化、智能化的整体解决方案和全生命周期的服务。那么我们中车呢，利用了我们的项目管理的强大的项目管理能力，从项目的设计研发到我们的实施，到我们的部署，到我们的运用以及后期的运维，为用户带来非常好的系统的集成方案和解决方案。那么今天我们为德国展呢带来是3大系统解决方案，它们分别是中低运量市域轨道交通系统、空轨智能集散运输系统，以及我们的封闭场景无人化智能运输系统。首先呢，我现在为大家介绍我们的中低运量城市轨道交通系统。那么可以看到，我们为城市交通它的中低运量的客运需求提供了非常立体式的交通的组织方式，包括我们的资源服、我们的自导轨系统，还有我们的悬挂式的单轨系统以及我们的导向轮各种导向轮系统，可以说可以满足城市区域的各种运量、中低运量的需求以及各种运输方式的需求，根据城市的规划以及建设。
可以看出它的这个应用场景还是非常多的，多样化的满足需求，而且非常灵活。
是的，可以满足我们各种的城市的规划的范围以及它的不同的区域的运量的一个需求和应用。那么这一部分呢，就是我们的空轨智能集散运输系统。那它主要是面向了场景呢，是我们的集装箱调运，就港口集装箱调运的这个领域，尤其它在于这个我们的自导向这种比较灵活的这个类似于 AGV 的这种导向轮的形式呢，它可以非常好的把我们的这个货运车直接的从空旷的区域运转到我们对应的地点，以及我们的这个道岔控制这也是非常考验你的这个系统的内部的调度运输的一个环节。那么压轴出场的呢是我们的封闭场景智能化运输系统。那么这个就比较厉害，它的应用的场景呢是针对于所有的工矿企业，像我们的钢厂、我们的化工厂、我们的物流运输站场。那么这个系统提高了非常好的智能化、无人化的解决方案。那么它应用于更高等级的无人化驾驶、智能化控制的功能用户会提出非常多的这些需求，我们去满足它的需求。其中呢，利用了像我们的智能感知系统，使我们整个系统具备了非常高的自我感知环境的能力，还有我们的智能装备，利用我们的无人驾驶、我们的自走行的技术，永磁电机的一些很多的技术，形成了我们的诸多的智能装备，完善满足我们各种场景的自动化的运输需求。还有我们的智能调度系统，可以和既有的系统接口，实现我们的任务的无缝衔接，完成各种特殊的复杂的任务流程。还有我们的人机交互智能运维，那这个界面呢比较有意思，它提供的是一个我们可以远程控制这个机车的一个功能界面。当然，我们也可以把它用于训练司机，也可以用于我们的实验室的仿真验证。那同时呢，还提供我们的运维的界面，可以让我们人员实时的掌握好系统的它的工作状态、设备的状态，以及相关的这个检修的建议、维保的建议还有一个特别有意思的就是这个数字孪生系统。那么在我们很多传统的工业领域呢，它的信息非常的复杂、离散。那么很多情况下，我们人员需要跳转到诸多界面去查看当前发生了什么，我们要做些什么事。那这个系统通过我们的高仿真的3.1建模，可以自动的分析当前的一些很多数据，然后直接跳转到对应的界面，让我们去查看当前到底什么作业在进行，我们需要做哪些特殊的处理，也是非常好的，具有非常好的应用效果。那我的介绍就是这些，谢谢安琪。
好的，也看到了我们刚才包括你讲的货运场景的应用，以及我们这个工厂的这个应用，它的整个模式还是非常多样的，而且非常的便捷，非常的智能，能让我们的不管是港口还是企业更灵活的去安排自己，更灵活的去掌握自己的经济性。
是的，为用户带来全方位的系统级的解决方案。
好的，谢谢你专业的讲解，谢谢。下面呢，我们就跟随我们的镜头呢继续向前。现在呢是我们的最后一个板块，我们的货运板块。看到我们的范文婷已经早早的等在了这里。文婷你好。
你好，安琪。
为我们介绍一下我们的货运板块有哪些亮点吧。
好的，欢迎来到货运解决方案展区。在正式开始介绍之前呢，我有3个关键词，安琪想让你和屏幕前的观众朋友们猜一猜，它们都代表什么含义。好了，我的第一个关键词是大力神。 我的第2个关键词是高铁快递侠，我的第3个关键词是绿色新能源。
好的。
那既然我们已经有问题抛出来了，那么我想你是非常了解我们的产品的，但是很多观众在镜头面前也许并不是很了解我们的产品，因此呢，我们就带着这个疑问来逐一的解开每一个关键词所代表的含义吧。好的，现在看到我们这个第一块屏幕上显示的是世界上轴重最大的45吨轴重的矿石车。这辆车的单车最大载重可以达到160吨，每一列编组的话有260辆，因此呢可以达到4.68万吨重载牵引运输的要求。当然了，就是我们妥妥的大力神。当然了，我们有了大力神之后呢，不可能没有大力士来进行匹配呢。于是呢，我们的24轴的重载货运机车、电力机车也就横空出世了。这个是世界迄今为止单机功率和牵引力最大的货运电力机车，可以在12%的坡道上实现1万吨的牵引，而且呢，它有具有非常好的灵活性，可以灵活的进行编组，可以适应客户的要求，并且呢，具有集成了智能的装备设备。好了，这个就是我们的大力神以及我们的大力士。
也是一个非常灵活的大力士。
对的，是的。好，那我们刚才提到了3个关键词，现在我们就进入了第2个关键词的解释。
我记得是高铁快递侠，对吧？
你的记性非常的好。现在我们就要解开这个高铁快递侠代表着什么。这个就是我们时速350公里的高速货运动车组。这个350公里的时速是一个什么概念呢？就是从地图上来看，我们柏林到法兰克福的距离是550公里，那么意味着350公里的速度呢，如果我们发运货物从柏林到法兰克福，只需要1个半小时左右的时间，货物就能够顺畅的到达呢。
那非常的方便啊。
对，这是一个非常快的速度。而且呢，这个车还有另外一个非常好的优点在于哪儿呢？它有非常大开度的侧开门，而且呢，它配合了标准化集装箱的这种作业。这样子呢，就能够非常明显的降低装载和卸载的时间，对于我们高附加值产品的运输提高了很多的效率，降低了很多无用的时间。所以呢，我们就戏称它为高铁快递侠了。
确实名副其实。
是的，这个就是为了我们解决了很多运输的问题。
对。
好了，第3个关键词还记得是什么吗？
是我们的新能源。
对，就是绿色新能源。这个部分展出的就是我们的绿色新能源。在中国中车进行设计和制造的过程之中，始终将绿色发展理念呢融入到我们的设计和制造产品之中。因此呢，就有这么一个系列化的新能源机车平台，可以为我们提供不同的工况和运输要求。这个新能源机车平台呢，它可以兼顾1000千瓦、1500千瓦和2000千瓦的功率等级。并且呢，具有3种的配置模式，分别是内燃发动机加动力电池以及氢燃料电池加动力电池的配置模式。因此呢，可以全方位的满足港口、冶金、矿山等相关的要求，还有他们的全新的升级迭代。这也是体现了中国中车平台化、智能化、绿色化、模块化的产品发展方向。好的，我的介绍就到此结束了，谢谢安琪。
好的，谢谢文婷。好的，谢谢。刚才呢，我们结束了我们的货运动车组的最后一个板块的介绍呢。那么现在呢，我们的今天的直播呢就全部结束了。在这里呢，也希望对我们的产品有兴趣的观众可以来到我们的展台，来进一步了解我们的产品。我们的展台呢，展馆在4.2展馆210号展位。也非常的希望呢，大家能来光临。中国中车一直与你同行。好的，再会。
啥会好？